All right, sound check. You guys should be able to hear me. You guys should be able to see me. Boom. Okay. So what are we doing today? I don't have a lot of time because it's date night with the wife, so I only got a little bit of time until she gets off of work. But I can hang out a little bit, talk about, you know, what does it look like to get into the field? We've got automation and engineering and all these different types of tasks and stuff that we might do. So I thought that I would just kind of walk through some actual job board requirements. I mean, we grabbed these a while back, but I still think they're valuable for you guys to see what the jobs kind of look like, and then maybe talk about what the skills are, where we go, pick up more skills if we need them. Because we have a bunch of stuff. There's all kinds of there's almost we were talking about this in the Discord yesterday. There's more stuff than you can consume. I mean, there's more doom scrolling to do. There's more technology things that there are to do. So you kind of have to figure out what's interesting to you and where you want to focus that time. You only have so much time, and if you try to do all the things, you're probably going to end up doing nothing. So I mean, that's probably the common state of the average person. So if you're trying to get into a field and you want to do Linux as a systems person, you need to go look at what the jobs are. So these come from actual job boards that we had grabbed. These are older notes, but we'll still go through them. I think that there's some good stuff in here around the different labs. If you're looking for these notes later, they're all in our Discord. So this was called actual job board requirements, and if you're looking where are those at, you go pop in our Discord over here and you go hop up into our notes section. Typically when I do meetings, here will be our meeting notes, and this was an older one that we had done, getting the job in Linux systems engineering. This same type of stuff, right? But then this one should be up a little bit. I did this a while ago. There's all kinds of notes up in here. Lab build out. Just my notes. This is another one, getting jobs. These are things that we could talk through. What does it mean to diagnose and resolve issues related to Linux? What would we do during standard business hours? What would we do after hours? What are the tasks that we do as a systems person, right? And I might even pull some of these out, right? Because I had put these somewhere. But then I dropped them down here so that we could go over them later. But these are the kind of tasks that everybody wants. And I'm telling you guys, when we break them down, it's the same thing. They want you to be able to monitor stuff. So you got to track stuff with the tools that are there. Maybe you need to help build tools. So you say, well, okay, what do I do with monitoring? Well, with monitoring, there's three things that we tend to monitor in systems, right? We monitor the metrics of the system, which are the, CPU, disk, memory usage, all those kind of things. And those tend to be recorded at a distance, so we call them telemetry, which means metrics at a distance, right? We monitor telemetry, we monitor logs, but we don't register and filter through logs nearly as well as systems do. So we tend to hook those up to SIEM or SOAR type solutions, and then we get information out of them. So there's a lot with that. And then the other ones that we tend to monitor are trace, so things as they move through our system, right? Like a web application call comes in, goes to comes in through a load balancer, goes to our application server, hits our database server, and all of those different transactions that are happening. Are we doing stuff with queues, whatever we're doing, we're being able to track that data. So there's three types of things that we tend to monitor, and it's good to be able to talk about this. If somebody asks you what would you monitor in a Linux system? Well, I would monitor telemetry or metrics. That's the big four typically: CPU, memory, disk, and network. Those four things need to be tracked, right, on the system. And then they might ask you, how you would build out a monitoring solution if we didn't have one. Well, I'd probably put an agent on a box, something like Node Exporter or Alloy is a newer one. We need to build some labs around Alloy. We don't have any of those. We do have labs around Node Exporter, but Node Exporter will expose information, and then a tool, typically Prometheus, will scrape that information at regular intervals to let us know that the server is up and that the server is functioning within the right and correct variables, right? Now, in the home lab, right, and what that might look like in my home lab here, we have, this is probably my most common one right here. that is all Prometheus. This is all Prometheus info right here, right? This monitor right here. This is all Prometheus info about my systems. I can drill in on any one. I can see that all the systems are good, right? This is a what we would call like a heads-up display, a HUD heads-up display, or maybe like a dashboard, like a NOC, Network Operations Center type dashboard, right? And as we talk about these things and we look at these things, it's good to kind of understand the terminology. So like if I say anything while we're talking here and you're like, what the heck's this guy talking about? Take it down as a note, look it up later. This is how lectures work, right? Like I'm giving you a lot of information. There's a lot of stuff going back and forth. If you have questions, feel free to ask them. I mean, we've got 2 places you can ask questions, over on Twitch or YouTube. But anyways, we're looking through this. I was going to try to find these specific notes. I'm pretty sure they're right up here. I'm pretty sure I have these notes that we're going through right now. Probably right before this stuff. Let's see if I have them. This was some good sysadmin stuff, which I think all this stuff is good. Yeah, so here's the actual, so it was from 214, in case anybody needs the actual stuff that we're talking about today. And these are all the things that we're going to be talking about as we look through this. So let's get back over here, and let's look a little bit at the service here. Make sure that's... All right. So what's the first thing that somebody wants you to do? If they're going to hire you as a Linux administrator, maybe even into Linux engineer, but although you're probably going to start out Linux administrator, they want you to be able to install, configure, and maintain Linux operating systems. Red Hat sent different flavors. Doesn't matter the flavors. It might even be Arch Linux. Probably not going to be Arch Linux, but maybe. They want you to be able to go through the build process. So let's look at that here in a second. I got a couple questions over on the YouTube side. Remember one of your Prologue courses, you mentioned something about having only lab experience on a specific area. You mentioned something about making this lab only experience sound a lot better. During an interview, do you recall this? I don't remember exactly that. Guanaco, I have probably more stuff that I've said I need to build than I have built, if that makes sense. Like I constantly say things on here, and if people don't keep me honest, I always joke around about keeping me honest, I'll go off and do other things, and I work and I teach, and I'm working on a dissertation, so I'm busy, very scattered about things. I have like 10 labs in process right now that I need to publish and finish. I just haven't done them, so I got so much. I'm super stressed. The dissertation, this next part that I have due by the 19th, so I only have 7 days left, and I'm kind of wallowing on some of the stuff that's due, and it's for a thing called an internal review board. But no, I don't exactly remember that, Guanaco, but I'll tell you, anything that you have on a resume is fair game in an interview. And anything that they ask about, so any of the things that they ask about here, you should expect them to ask you about. So if they said, how would you install, configure, and maintain Linux operating system for us? Well, I would start by saying, well, I assume you have a build process, and I would follow that build process. But if I had to install Linux from scratch, I would get a hold of an ISO. So I would get a hold of, let me see. So like an ISO, let's say I just wanted to build a Linux box out here, and let's pretend we were going to use this Red 1 server. We go to the console, and I would, I need to reconnect. Hold on, I got to reconnect some storage stuff here to be able to show you guys this. Let me redo. I do need to fix this, but once we repair this, that box will be back up. Yeah, that's fine. We can. I can show you this now that it's connected. So the problem is there's a race condition, and this don't worry about that. None of that matter unless you guys care about that stuff. Right now, though, what I would do on a bare metal system, if it were bare metal and I could get to it via IPMI or local, I would attach an ISO to it. So some server like this, and I want to install, let's say in this case like Rocky 9.4 because I have the ISO. Then I could go ahead and start this server up if I have the space for it on the machine, which I think I have the space. I got enough memory to start that box. So I could start Red right now, and it would go, if it were set to boot from the ISO first, which I can go set the boot order if I need to, this will boot up, and at the console I will see it mount that ISO, and I could install the server from scratch there. Now, this is going to go into, in a Red Hat sense, this is going to go into what's called the Anaconda installer. And the Anaconda installer, so no, this is booted to Ubuntu. Unless I were to, I have to go modify this at its boot order. So let's go ahead and force the shutdown on it. I should be able to come over here and change its boot options. And it goes, look, it goes hard disk and then DVD. Once it comes down, I can change those properties, right? Where's that boot options, right? I can grab the DVD and move that up. So now when the system boots, it's going to boot the right way, right? Let's just hard start it. This, though, very, very quickly, if I started to explain this to you in an interview, you would say, well, that's not a super efficient way to build Linux boxes. I need 1,000 of them built. And I would say that's true. This is only a manual install, maybe if you were doing a one-off build. This is very much like what we would call, yeah, so look, I could test the media, and I can go through and do whatever. And I could install it on this box if I wanted to, right? Again, through a GUI, graphical user interface, and then with what we would call like options driven until we click next until we were done, right? That is not the efficient way to build Linux servers, though. That is the way that when we first learned, like if I was teaching any of you guys how to do that right now, which we're not, we're just walking through the tasks that you need to go learn and spend time with to be able to do the job. If I were teaching you right now how to build this, that would be where I would start you. We would walk through, we would talk about the options, and you would start to pick up a whole bunch of different things about Linux by installing Linux. That's kind of that. Now, that being said, that is a way to get Linux out of box. When we have a stateful node, maybe like a head node that stands up in an environment, we sometimes still build Linux servers like this. Not often, guys. It's not often that I build a Linux box like this. But sometimes if it's like a high-performance compute environment and it's the first of the servers that come up, we do sometimes build them like this to get like the head nodes up. Once we have the head nodes up, we harden them with like an Ansible playbook, and we get them to whatever we expect them to be at. But now this box, this thing's gonna test, and it's going to boot into that CD, and it's gonna do a check to make sure that the ISO has no problems. We could mount any other system on here and build any other Linux. Sometimes you even have stateless boot disks, and like you guys probably remember the old Knoppix with the bootable. So that's one way to build a system. And if I were talking about the build process, depending on what type of job I was looking for or going for, I would talk about this is the build process. We gather requirements, figure out what versions we need. We got to figure out how we're going to support them. Is this a brand new project? Are we building onto other systems, right? So requirements, that kind of stuff. How are we going to do the inventory of the nodes? Where are we going to keep track of those nodes, right? This kind of stuff. Early decisions, are they going to be stateful fat machines? Are they going to be physical or virtual servers? Are they going to be physical servers that are then virtualized inside of them? So now we need some kind of hypervisor. These are all things that I might not know in a network when I'm first building stuff. We can have stateless nodes. Stateless nodes are not immutable. We can change stateless nodes. We just don't change them through a reboot, right? And then this is what I was talking about. ISO. I can mount an ISO into a virtual drive via iDRAC or IPMI. That's control methods for us to get to servers and mount something like this to check the system or to build. That's a way to do it, guys. This right here. But maybe what we normally might do, and this is what I was saying from like a high performance compute. Once I get those first couple of nodes up, maybe I use them to build all the other servers with like a NetBoot or what we call an iPXE environment. And iPXE, I couldn't tell you right off what iPXE stands for. I forget what the acronym means, but it's basically a virtualized boot from another server where it pulls down and inflates an image, right? And all nodes can boot from that image or set of images. And this is much more the preferred way of how we do a lot of this stuff nowadays. So if we were talking about the build process, I might say, well, I'm going to stand up a set of images on like a server. And in my case, I'll pull up, let's pull this up on the right side here so it's out of the way. Here's my Werewolf server. And Werewolf server is just another provisioning type of server. It's a system that allows us to provision. I have a whole thing on it, and I might even be talking about it at scale this year. I don't know if they need me to or not. But in here, I can list the images that are there, and then these images can be set as a node comes up and boots, it can iPXE a net boot off of this. I'll show you what that process looks like here in a second. But I can say like www.ctl node list -a target 1-1, and the target 1-1 server says he's going to boot off of target Linux 9. Target Linux 9 is right here as a image, and when he boots up, he's going to get all of this stuff about himself, right? This node. He's not going to know, there's nothing stateful on him on his disks. He's going to boot up and go to a tempfs and start. So this is a lot of stuff I get, but this is also stuff that we do in the industry, right? Not all servers are going to be stateless, though. A lot of times we do stateless in high-performance compute. Some companies are very risk-averse, and they just want big, fat, stateful servers everywhere. Even in the virtual machines, they're all just stateful. When they turn off, they turn back on. We got to maintain those types of servers through patching and updates. I often say it like this because I've had to do this a lot in my career. I am patching and maintaining a fleet of aging servers that are constantly getting more and more vulnerable. That's what's happening to them. They're servers that are built on, Red Hat 9.3 or Rocky 9.4, whatever version, and we're moving them forward over years of their support, and they're gathering changes, and it's just, even if you can glaze over those changes and make the system pretty good, it's still deviated so much from the original build that we have a lot of problems with them, right? So these are the things that I would talk about if somebody asked me about, like, system deployments and where you might come into problems and all that stuff. I'm just giving you guys like a wide thing as we're talking about building servers. So again, you could build servers like this. We're just doing a system check. We don't even really care about this box. In fact, we'll just go ahead and turn him back off. But that was mounting an ISO. We'll eject the ISO so it's no longer mounted. And that was over NFS. So a system had an NFS share up. That device mounted that. It's the same as me going and putting a CD in back in the day, or nowadays you might take a USB like this and go plug it into the server to build it for the first time. That's a common way. Well, in a virtual machine, we don't have that, so we mount the ISO, right? And then the ISO comes up as one of the boot options. You saw this system could boot network, disk, or ISO, or like CD, right? Those were the three boot options in here. Well, let's go to one of these other servers, like this Target box then, because Target's the one that we showed right here. And this server, he's going to net boot. He's going to come up, and he's not going to have, this is a stateless node in my environment. Let's go ahead and reboot him and see what happens here. This is another way that we would build Linux systems, and this is another way that we would, if somebody said, how do you build Linux systems in an environment? I would say, well, we could manually build them and then make that into like a golden image and then deploy from that golden image and modify it as it comes up for stateful nodes. Or we can do image-based stateless like I'm doing here. And what this node's going to do is he's going to boot up and he's going to go through a process called DHCP. A lot of systems that you deal with daily go through DHCP. Like your desktop at work probably goes through DHCP. Your phone probably does. It's basically, we're not statically assigning it. Most servers do have a static assignment. In this case, look, he did a DHCP request and said, who am I? I don't know who I am. This server knew who he was based on his MAC address. He's got a MAC address right there, 669A. 669A, right? We knew who he was. So now he's going to go pull down and expand out there's two things he's got to pull down, the kernel and the initramfs, right? He's going to boot up, and then he's going to do a switch root over to his tempfs, and then he's going to be, for all intents and purposes, the brand new machine that's been started, right? So, if somebody were to ask me about this, we're talking about job requirements, and we're looking at real job requirements. So if anybody got here late, I'm looking at actual job board requirements. And the first question somebody might ask or want to know that we know about is, how do you install Linux in a system? Well, you can do it through an ISO install and then walk through like a Anaconda installer or something. Or you could build a golden image like that one time and then keep that and keep deploying it to different servers, right? Like basically copying it around the environment. That's a common way to do things. Or this way that I'm showing, which is like an image-driven net boot from a configuration centralized environment, like I'm using Werewolf. There are other ones. There's so if you're saying, well, what other ones are there, Scott? There's XCAT, there's HPCM, there's Werewolf, of course. There's the old Beowulf back in the day, but Beowulf was kind of specialized for smaller environments. And then you might say, well, where would we use this Werewolf one? Werewolf's super popular, guys, in the high performance compute world. I've deployed now probably close to 15,000 servers in the last year, using Werewolf as the underpinning of the deployments that we were building. So I work on teams. I work on a pretty small team. There's only about 5 of us, and we go and we do deploys. Well, we do them I do them from my desk right here. I don't go anywhere. You don't need me to go anywhere most of the time. Although I was supposed to go somewhere. Actually, this week I was supposed to go out to Ohio, but it looks like it got pushed back to February, and I have to go give some training on one of these big clusters that we've built for one of our government customers, right? And look, that server came up. It's stateless. It has no memory of this place. It's like a trap door that falls and comes back up. There's nobody on it anymore. It's back to clean. So that's kind of the ways that we would build a Linux environment out for people. And there's nuance there. There's a lot of stuff for us to talk about in that. But if we were like sitting in an interview and you said, hey, could you just enumerate real quick the ways that you could build out a Linux box? I could mount an ISO, build it by hand. That's not efficient. I could take a golden image that we've built and saved off and clone it and then customize that server with scripts and Ansible playbooks and those kind of things. Or I could have like a stateless container, stateless node type situation where I deploy from some centralized server. And those are 3 pretty common ways. I mean, that would, in my experience, that would cover like 97% of all server deploys I've ever done. I've done very few other. I've done a few in my life where we've like cloned a disk and then walked a disk over to another machine and then manually changed it. But that's pretty rare to do that kind of thing. But you could, right? If somebody was like, Scott, give me a list of all of them or I won't hire you, I'd be like, well, give me a minute here, right? Excuse me. Hi guys, I've been talking and now I got like phlegm in my throat. Hold on. Currents, I see your question. So Current said, is Ansible better for Red Hat Linux machines or it doesn't matter type of Linux? Red Hat doesn't. So Ansible works for anything if you can do these things. Let me show you guys. I got a little talk on Ansible. I'll pull it up for a second. Pull up my Prolog presentations. This might not even be in my. This is. Let me open this with Google Chrome. So this is an old talk I gave at my company, Redline, right? And it was Ansible Tower Automation with AWX. So my company that I work for is Redline, and this is an old talk that I gave. But I'm just really going to show you one slide here to answer your question. The reason there's a cult of Ansible, guys, is this right here. I'll show you. This is the cult of Ansible. People are like, everybody's always talking about, once they see it, it's so cool, and they like it, and they always, here's why. Because when I go to configure things with Ansible, I don't need an agent on them. It's not like Salt. It's not like Puppet. It's not like Chef. I don't need a running agent on my machines to check on them. Ansible just needs 2 things. SSH to get in, well, or another connection, a connection method. SSH is the most common Linux one. And then it needs Python. If it has those 2 things, a Python executable environment. If it has those 2 things, it can configure a box. And I use it on, and well, I'm a little out of this, so I can't really say I currently use it, but I ran at AAA. Some of you guys know I was at AAA for years, and I was their platform engineering lead. So I did all the Linux and Windows. And on the Windows side, I would use WinRM to kick off PowerShell scripts, right? And build systems. So WinRM is 5985, but if you use the certificates, it's 5986. If you care, and then SSH. So I have to have a connection method and then Python. Those are the only things I need. Yeah. Ansible and Chef, and some of these things have different purposes. Chef is great for initial deployments. A lot of times I've seen companies do that, and then they go on the Ansible side for Ansible breaks more. And well, it's not for everybody, right? Like, and there's different reasons to use it. I also use Ansible when we're back in this like NetBoot environment. I use Ansible to configure images in what we call a chroot, or some people chroot. I don't care how you say it. I say it both ways. But in a chrooted environment, you can go in and modify these disk images. And we're not going to do it right now, but if you guys needed to, I think I have. Am I in? Do I have it here? No, that's something else. I was looking. I thought I had maybe it's Stig remediation. If I could type Stig, is it in here? Did I actually do? Yeah, here's my Chroot. So when I was modifying these nodes, like Target Linux 9, when I modified this a while back, and I think if we're just messing around, I think I was just doing this. I was using that Chrooted environment to fix, and I was showing people how we harden, because once we have a box working, we can then harden it and we can back out images. There's a bunch of things we can do, but this is part of that's like a hardening thing. Hardening Linux and securing Linux is tremendously important as part of the build process as well. I have, for people who care, I have back over here. So I think Ansible's great. I think there's a whole cult around it, and we joke around often about the cult of Ansible. I was going to show you guys this for people who. Let's go back to security course. If you were like, well, Scott, how do we harden Linux boxes? I mostly have you guys hardening them in this lab of our course books. So if you guys have never seen our little course books, they're all free, right? We just have them out there for you guys. The dudes did a really good job. Our team did a really good job of putting this all together for you guys. But if you look at it at a wide enough screen, it's just got all that there. If you guys need this, this is, again, like the team behind the scenes of all the Prolog guys. They did all this stuff. I actually have to do something for those guys for Christmas. But they put this stuff together. If you're ever looking for it, it's all in an open GitHub. You can see how they build this with Markdown docs. They do a fantastic job of like laying out the books for the courses for everybody. Like I just kind of threw everything at the wall, and then they turned it into like nice books for everybody. So those are the books. If you guys need them, they're free. Go do whatever you want with them. Anyway, so where were we at? We were talking about the build process. Oh, and then we were going down into like monitoring the system. This is kind of the next thing. So they're going to ask you to monitor system performance and troubleshoot issues related to server hardware, operating systems, and software. So you'll never get away from the word troubleshooting if you're in an admin or an engineering concept. People will always be talking about that. Yeah, Currents, you said try and make yourself more marketable. If you want to learn Ansible, right, here's a free set of topics to go learn Ansible. Hold on. So Killer Coda is my favorite thing to show people. And here's our Ansible labs. I built all these. So if you do these labs, right, if you get stuck on any of those and ask me in Discord, I'll try to help you out, right? Let me drop this over here. These are free. That's my favorite thing about Killer Coda is you drop like this. Like you say, hey, I want to learn a little bit of Ansible. I've never done any Ansible. I need to get my first playbook. And I say, okay, here's Ansible. Like you drop right into an Ubuntu environment, and again, I tell people all the time, I think this is the best free thing on the web, because if you were like, hey, I got a little bit of time, hop down the voice channel, we could be in the exact same environment looking at the exact same thing, and questions are easy to answer at that point. So like a lot of times when I work with people or help people, and I tell people all the time, if you catch me in the Discord, which I'm always in the Discord, if you catch me in here and need anything, just let me know, ask me a question. Right? And I tell guys all the time, I always tell people this, if it's something that we can do in front of anybody, like if we can talk through it and work through it, and I have time, I will do it for free in any of the channels, right? We'll just hop down there and work, people attached, and we'll do stuff. If it's something like for your company and it's something like that I have to do like in closed doors and stuff, my wife will be mad if I don't charge. So, but I will definitely, I will at least like look at something if you guys need. Just don't send me anything proprietary. Jeez, please. Don't do that stuff. I've never had anybody do that, but I'm saying like be careful about that kind of stuff. But I'll definitely look at stuff. But the thing I love about this one is like we can install Ansible, and then we can look at the version. It takes a little while in Ubuntu. We can go maybe the Ubuntu version is slightly different than the one that you use, and then you can go look at the stuff. So let's get I'll just do this real quick. You guys can see. And the way that my labs work is I drag you along. You can just hit the buttons and it'll do it. But then I kind of ask you questions. I do have a book on LeanPub, and that just has more questions and it's like more journaling. But I tell people all the time, you do not have to do anything with LeanPub. You don't have to pay for nothing. Just hop in here and do the labs. And then if you have questions, go back and do that kind of stuff, right? Like if you want to dig in deeper, that's for you know. Or I tell people like when you're like in the industry now, then you can go back and buy something. But I tell everybody else, you don't have to buy nothing around here. You guys just you don't have to pay to kick it, right? As they say in the where I grew up. All right, hold on a second. This is taking a little bit of time, but it'll come up here, and then we'll check the Ansible version, and then we'll throw that in a file, and then that'll allow us to move forward in the labs. Also, these labs are up on my GitHub as well, like how you build labs in Killer Coda. You guys could build labs now if you had anything that was interesting to you. Do that. Let me text the wife real quick. She just messaged me. I must say I'm streaming, so that's good. All right. So, oh look. So now we look at the version. We put the version down into a file so that the thing knows to move us forward. And then we can go check a bunch of other things. One thing I like to show you guys, and I don't think I say it here, but when we installed Ansible, I like to type Ansible dash and then just hit tab a few times. Tab is your autocomplete. It's like your best friend in modern Linux. We didn't have this back in the day. But those are all the things that I might go look at. And then I can RTFM, right? Read the field manual. It's not what it means. Go look it up if you want. RTFM is read the field manual for our purposes. And I can read the field manual about each of these things. Or I can go like look up like, hey, how would I use Ansible Vault? What are some use cases of that? And I have some Ansible Vault stuff in here in the labs. But the point is you could start to figure out what tools are there and what different functionalities exist and this and this and this. So all that to say, I think we're still on builds for that. You shouldn't do, like I said with the ISOs, and then we build something by hand. That is not the modern way. That is not the efficient way to do things, just clicking next, next, next in an Anaconda installer. What we would do typically is do that maybe on one server, and then we would set a hardened image or like one of these bootable images that we use in Werewolf, and we would harden that with like a playbook so that we don't have to go, because there's like 400, if we look at our Stig view, this is going to get bright for a second, I apologize guys. If we go look at the Stig viewer, right, and I don't have current Stigs, but I have some that I was using last year. I haven't done Stigs in a little while, but Stigs are your secure technical implementation guidelines, and this is all free, right? This is all DISA Stig stuff. There's 452 Stigs for RHEL 9 Linux. I'm not doing that by hand, guys. Even if I could just go in there and do that, that's not efficient, right? That's not an efficient way to do it. Like if I go look at one that's very common is maybe we look at sysctl, right? So here's all the individual sysctl, like kernel dmessage restrict and kernel perf event paranoid 2, and like all of these, I'm not going to go do all of those one-off changes and make one-off files and stuff. I'm going to use Ansible to push that. Actually, I have that somewhere in my lab where I have like a file that I go and I push and I fix like 30 of these all at once, because then the system has those values, right? We get into this a lot. We use this Stig viewer a lot in the security engineering course, and that's free because the security engineering course is free in Discord. The reason we do it is to harden a system for government stuff, basically. But also, I make you guys go through it because I want you guys to see the security considerations that are there. The worst thing I could do, the worst thing in my mind, the worst thing I can do is not teach you anything, because I think that would be terrible. We'd all just be wasting our time here. But I think one of the worst things I can do, let me make that a little bigger, is like, let's say the security engineering course, we go all the way down, and I say, okay, here's the 10 things you're going to do in the security engineering course, right? We do it each week in the Discord, 1 through 10. We just finished Unit 10, so we'll probably restart this again in a few months, right? We do it every few months, and then it runs for 10 weeks. The worst thing I can do, honestly, as we talk about this, is just make you like a Stig or a checkmark monkey. That's not good engineering. That's not good. I wouldn't feel good if that's if that's what I was teaching you guys. I mean, anybody can go become a checkmark monkey. What I want you guys to do is understand these things, weigh the things, be able to set them. Well, you got to be able to set them, right? But then also, if you have to push back with your security engineering team, the ISSOs, Information System Security Officers, if you have to push back and say, hey guys, we can't do this compliance thing because of this. We have this mitigating control. Now you're talking in controls, because controls are a big part of what we do. In fact, I think the guys even have it right here on like the worksheet. Like, what are the types of controls? Maybe, I know I for sure have it in the presentation, but What are the types of controls and stuff. Anyways, that is where, again, so as we're talking about these, that's where I would go to learn more information about the build process and getting better at this stuff and all that. All right, let me get the Ansible stuff out of the way. I think that's a good place to go spin off for people that want to learn how to use Ansible, because I really do think Ansible is one of those things that can change the direction of your career if you want to go spend a little time. How's it going, Fisherman, with the most cursed? I hope that's a belly button that we've ever seen. How's it going, guys, over on the YouTube side? I've been missing stuff because I'm just kind of talking. These are actual job board requirements that I just kind of filled out some notes for. So here's somebody wanted us to know how to install Linux, and we talked about that. Now we are down here on like monitoring systems, and I was saying that like we can learn the individual pieces of this, right? Like I have a presentation. We're not going to go into it too much now, but if you go into presentations in our Discord, and then you go to, it's called Linux administration. So it's it's not too far up. I think it's before all the AWS. I think I was up a little bit already. It's called Linux administration. Look, there's Fisherman's presentation right there. Where's my Linux? Kubernetes. My brother Tom, when he came to talk to you guys, different people doing Prolog sessions. There's all kinds of session stuff up here, and just information for you guys to go through if you want. Where's my Linux admin stuff? I know I have it. I just want to make sure I'm not lying to you guys. Linux sysadmin, and it's right here. So what I'm about to show you guys is there if you need it. But let me show you guys. Let me pull this up for a second. Linux systems admin. And this one is, we're talking specifically around monitoring system performance and troubleshooting issues, right? There's some things that we should know how to do in a Linux sense. Let me get this other stuff out of the way. It's a different talk. And let me just real quick show you that there's administration tasks. There's a bunch of things that we do. This is how I troubleshoot things and look at things. I look at how utilized a resource is. I look at the saturation and the errors of it. We're not going to dig into that too much right now, but how do I observe things? There's a bunch of tools that I use. And then when we get to the big four right here, this is like a page that I don't think you need to memorize, but you should understand how to look at this. So there's the utilization of your CPU, your memory, your disk, and your network. Those are the big four. Now, disk gets a little tricky because there's two ways in which disk can be utilized. It can be utilized in I/O, which is throughput down to the disk or out. That's one way a disk can be utilized. And the other way a disk can be utilized is how full is it across two areas. This gets kind of complex. One is actual space, right, in megabytes or gigabytes or terabytes, petabytes, exabytes, yottabytes, whatever. Keep going up. Or in inode count. And inode count, most of you will never run into in your career. But if you're a Linux engineer and you deal often in big storage, you will sometimes run into it. I've ran out of inodes twice in systems. Both times they were GPFS, global parallel file, global parallel file system. It's the IBM one, and it's a big, and then you can just reallocate more, and then you have to monitor it. But the point is, you can go and you can type in commands all day for observability. But I wanted you guys to think about something. I can show you guys these commands, and you guys can go find these. Every time I do this, I have to nod to the best place on the web for Linux monitoring. Does everybody here know where the best performance monitoring is? It's a guy named Brendan Gregg. This is the best, the absolute best. This is the standard. This is the gold standard on the internet right here for Linux performance. This guy. eBPF, all of the new technologies, all of those things, you can find them from this page. This guy, I've never met this guy, but I know people that have worked with him. Brilliant. Like all of this stuff here is like the standard. So if you want to dig into it and go spin off that direction, that's where you go. But back to my point for a second, because I know I move around. I can show you this. He can show you that. There's a million things. Can I make a manager do this, though? I can't. And could I make a network operations team member, like maybe a junior knock working third shift, some of this? I'm not saying they can't, guys. I'm not, like, everybody's capable, but are we going to really put them at the helm in root doing some of these commands? Probably not. So one of the maturing within an organization ways of getting, like when we talk about monitoring, and there's three things that we monitor. Again, metrics, which is distant metrics, so telemetry, you'll hear people say, but metrics like this here, monitoring my system. There's logs, what's going on in the logs, get logs off the system, that kind of stuff. And then there's trace data, which is how the data are flowing through the system. Those are the three things we monitor. Well, let me posit that the sysadmin stuff I just showed you, which again is in our Discord, you can go loot it like a cartoon villain and run off, I don't care. Let's say that you learned all those things and you were the best ever at those. You can't give that crap to a manager. He's not going to go type SAR-R and know the day and go back to some, no. They need stuff like this. You need to feed them. You need to take a little spoon and fly it like this with like a little airplane. Hold on, wait, do I have a fork here? Yeah. Here you go. Here you go, manager. Here you go. Open wide. Oh, put the food in there. That's what we got to do to management. We can't put them at a command line. We can barely put other users at the command line. Again, I'm not trying to shit on people's capability. I'm just saying they're not going to learn it. Guys, I've been showing managers and like project managers and other people this stuff, and I'm like, oh, you want to see this cool thing that I built so you can report it for a meeting? And I'll start showing it to them, and their eyes will glaze over. They'll be like, oh, command line. Is it done, Scott? Yeah, it's done. Okay, I'll go report in the meeting. And then they'll make me go to the meeting with them, and then they'll just say all the things that I said, and I'm like, what the? Why did you bring me in the meeting? You could have just said the things. You didn't need me here. Anyways, my point is we build dashboards. So we have these different dashboards, right? And the dashboards might show different pieces of information that are useful to us. So I can see, is this my other server? I can see how up the servers are. They've been up because they all got rebooted back like I think on November 4th or something. I can see that they spike CPU and memory daily across my environment, but I expect that because of a certain reason. I'm running my antivirus at 3:14 a.m. because I run it out of etccron.d, right? And I know that these things are supposed to happen in my environment. So then over the last 7 days, so this is 7 days of historical usage, I can kind of see that my utilization is where I expect it to be, and the capability of my system. I haven't run out of network storage. I have network storage still, and my servers have not run out of root storage. Those are things like heads up that I want to see, right? So monitoring system, again, as we mature away from us monitoring it, we have to give different stuff. And this is not this isn't necessarily us sitting here talking about all the storage proclivities, because there's a lot to get into with storage. I talk about that in some of the books. So if you go back to like the admin course, there is some monitoring stuff, and we set up monitoring. And I don't even dig in there, but it's like you have to think about your audience. There's really good, if you want really good, like what should I monitor and what should I show people, there's the SRE Google books. These are free books that Google publishes, and they will help you to like talk about service level agreements, and they will help you to talk about service level objectives and then service level indicators, and they will show you how to build a program around this. I can show you how to set up the tools. Like the tools of Node Exporter and Prometheus and Grafana, that's easy. That's over here in my, if you go to my Killer Coda, there's a bunch of stuff that I show you how to do all that. It's in it's in my Linux stuff. So if you go to Heptanus and then you go over to Killer, the Linux Labs, right? We have all the monitoring stuff. In fact, I got to make some new ones for Alloy, because Alloy is kind of the preferred way to do it instead of using Promtail anymore, right? So Promtail, we even use Node Exporter, and then we use Telegraph with InfluxDB as well, which is a different way to get data into a time series database, but it just depends on how your organization wants to do things. I wouldn't build all the things out. I would only build the ones that were maybe interesting. When do I find myself using? I don't really use eBPF very much. I just know that it's there, and I know that I can get down into it. There's a tool that makes eBPF a lot more usable for people. It's called Falco. I think it's falco.org. You can just get it. And this is one that will help out if you really want to dig into that. That's for container stuff. So you use it a lot with tracking like calls, syscalls, and user calls coming out of like containers. That's where I know to use eBPF, but I'll be honest, like I did all this stuff a few years back. People that have been hanging out with me for a while know that I did a bunch of cloud certs, I did a bunch of Kubernetes stuff, and then my career didn't really stay that way. I stayed kind of down in HPC because I love the company I work for. I love what I do with Redline, and so while I have all this like other knowledge, I don't really get to do any of that cool stuff. I'm over on big high performance compute stuff, just like making sure that the systems are the same and the the back end storage is good and the networks are good and that kind of stuff. The build process stays good, that kind of stuff. So yeah, anyway, so that's that. Yeah, but eBPF, there's a lot of reasons to use it. Mostly for me, I've seen with containers, but I don't get to do any of that stuff professionally, unfortunately. Oh, M-Man said, Brendan Gregg, smart guy, I used to read into it. Yeah, he's got some good books up there on his site still, too. And then I got introduced to him a few years ago by a Red Hat engineer that came to talk to us about performance tuning. And he did about a... Too many. He came and did like a training class with us when I was at AAA, just on like performance tuning systems, using TuneD or not using TuneD, or tuned. I don't know how to say that because it's tune and then it's the daemon. I don't know. So it's tuned or TuneD. I don't know which way people prefer to say that, but whatever. It's a system profiling tool. But I always caution people. My problem with that was. Like I'm an engineer, I have to be like this with my systems, right? And if you go do like if you turn on AID in an environment and then you do a tune profile and change to like SSSD or like AD or something, when you change the profile and go look at all the things that changed in the back end, oh, it's a configuration management nightmare. So I don't use that tool. I use pieces that come from changing in that tool, and then I'll use Ansible to change them. But I don't use that tool. Now, enterprise Linux companies like Red Hat, I'm going to use Red Hat as an example, but this is true of all of them. They always love to sell things to like the project managers and the other people, and show it as like they're like, well, this is it's what we call what's that called when it's ready after beta testing and all the testing. It's called GA, right? Generally available. It's good. It's ready. It's ready to support. But almost universally, when they do that, they don't actually care they kind of care. It's like gilding. It's like lip service to show the management that this thing was turned on. But then the engineers that have to support it, like all the stuff changing in the background, it's like it's a nightmare. So like then there's like this disconnect, and they're like, well, the vendor told us to just use that, and you're like, yeah, but you're not the fucking one that has to answer to GRC. Right, you guys all know what GRC. They're your governance, risk, and compliance teams. They come around with clipboards and yell at you for shit that changed in the environment. And that thing that you thought was just a light switch because the vendor told you that is something that changes 100 things on the back end that I have to report to. So yeah, I don't use the damn tool because it doesn't. You know what I'm saying? Like, it's I don't know. Anyways, sales will always get you if they can, because they'll sell this perfect gilded thing, but underneath there's all this other stuff changing. And yeah, go mess with your tune profiles on the system and see what happens sometime. Turn on AID, track everything, and then watch what changes. It's a lot. All right. So anyways, I'm not here to get on a high horse on any of that stuff. That's just vendors being vendors, trying to sell their stuff as being more useful than something else. All right, so then we implement and maintain security measures to protect Linux systems from unauthorized access, malware, and other security threats. All right, so we build to a standard, right? I would have to know maybe that we use the CIS benchmarks or the STIG benchmarks, right? The STIG is the Secure Technical Implementation Guidelines. This is the Center for Internet Security, I think, like something like that. But they've got a bunch of benchmarks. You can download them free, but it's not really free because you got to give them your email. But just throw off your work email, and then you can download whatever you want from them. Or you can go find them on the web. I know people post them. But then, do we need to be FIPS compliant? That's your Federal Information Processing Standard. Most things don't need to be FIPS compliant, but if they do they have to be, so the standards tend to be called the 140-2 or sometimes 140-3, depending on what you're doing and some other stuff, keys and stuff sometimes. But there's different FIPS standards, and typically you have to turn that on at the kernel level. Not all of your operating systems that some of you guys like to use can even turn FIPS on. A FIPS compliant kernel, the only ones I know for sure are like SUSE can do it, which is SLES, SUSE Linux Enterprise Server. RHEL can do it. Rocky can do it. I imagine Ubuntu can do it. Actually, Ubuntu does have FIPS compliant kernels. But a lot of these other ones that people love to play with, and they're like, well, Scott, why don't you focus on those? Because nobody's using them. Like for secure stuff, nobody can use that. Then do we need SE Linux on? There's a lot of secure Linux that has to be turned on or something similar, and it's more labeling on top of the file system, right? We do process level labeling with SE Linux, and then we give access based on what the process is. So it's just another way to kind of it's not containerization because it's with labels on processes, but we can like scope down what things can touch in an environment. And that's SE Linux is one of those things where for years it was just turned off in environments, but now more and more, especially on edge nodes that connect in and out of high performance compute, we have to have these two things on. Within the high performance compute cluster, we don't always have to do this. But the point is, we know how to build a system that adheres to these? And yes, we might go take our STIG tool here and harden a box like this. And then you say, well, how would you harden that, Scott? Well, you might come and download, like I'm down here on my Werewolf server, in root Ansible STIG remediation and then rel STIG 9. This is a Git deployment that you can go download. And if we go into like our tasks here, these guys have, so let's go, there's 3 categories of STIGs. Cat 1 have to be remediated. Cat 2, so they're high. Cat 2 are medium and Cat 3 are low. But let's go to like Cat 2 because that's where the most of them are. Whoops. Let's go in here and then let's go look at some of these. So we'll just look at like this one. We might even view this. It might be easier with view. Right, and then let's, right, so you guys can read that a little better. And here is one of the STIGs. So this is rel 09211020, and it's patched, and it says rel 9 must display a standard mandatory DoD notice of consent banner before granting local or remote access. Okay, so we're gonna set up a banner, and we're gonna put that banner into the system. And right here, it's going to use Ansible line and file to add the banner if it's not there, and it's going to, so here's the regex P is it'll find this banner if it's commented out, and it'll add banner etc issue, and then I imagine this one also pushes etc issue. That's probably pushed somewhere else. But now, where's that file at, right? So the line is banner etc issue. Let's see if we have that. We're going to just quit out of there. Let's go up 1 and CD down into, oh, we'll go back to Cat 2. Let's go, do they have, let's try this. Just find banner. And where's that consent banner? We see that. Banner etc issue. Does something copy? Where's etc issue copied in? So we copy in an etc issue on one of these, right? And then it looks like they're. This one's a little different than the one I normally use. But the point is, we can go and we can look at each of the different things that are happening, and we can analyze, like, do I actually need that for my build, or I can pull it out if I don't need it. Nobody says, like, when you download some thing off the internet, and then you go and you align it to what the actual STIG says, nothing says, like, your internal company doesn't need to have a DoD banner. You might modify that banner and use something else, but you're not going to perfectly adhere to a STIG standard. But look, this is rel 09211020, so I should be able to find 211, likely, 020. And if I can't, oh, so there's a STIG. Let's say 211020. Is that what I said? Let's get rid of CTL, remove that filter. 211020, is that right? Add that filter down. Don't find it. 211020, huh? So maybe we're not going to be able to find that way. We could also look for where etc issue is pushed, or we could look for banner, right? And then we can find where that banner one is. There it is. That's the one. So this is the rule that Ansible playbook rule aligns to. The reason you might say, why would you pull up the STIG viewer and look at it here when you could just do it in there? Well, because this right here, from this I can generate what's called a checklist, and then the checklist we can keep track of, and typically we do this automated as well, and we would keep track of all of the things that have changed in the environment, and we would be able to then hand this to an ISSO an information system security officer, and show them how compliant our system is. So here's our STIGs that we're using, and here's our compliance. We're not compliant at all anymore. In fact, we don't even have, I don't even think we have any number, yeah, we don't even have like a number here yet. So then we come down here and we start saying, okay, well, this has been reviewed and it's not a finding. Let's say we know that that's good. We do this. This is not a finding. We know that it's fine. We'll start to get a score. There will be a score actually published right here on the right. So now we're at 0.44. That's not very good. We want to get over 90. So we got to keep knocking these out. In fact, if we were to work on all the Cat 5s, let's say that we knew all of our Cat 5s were good. We just set them all to not a finding. That would push us all the way to a 5 out of 100. So it's not great yet. And then let's say we could take all of these. Let's just say we could do this. I know we can't, but then our system is at 96.4. So that's pretty good. That'll get you in most government stuff. And then, you have to have typically your finding details that prove whatever you said. So, if I was on a Linux box like this and I do like a sysctl-a grep for like ICMP or something, and then over here there was maybe one of the STIGs that had to do with, let's just clear this all and say ICMP, and then maybe one of them was let's see, we need to have net IPv4 conf all except redirects. So we're not accepting redirects because we're not acting as a router, so we don't need that on. So is our accept redirects all turned off? We need to call that, that's accept redirects. And that is all. Yep, accept redirect 0, so that's good, and I would know that that one was good. And what I would do is I would actually grab this and I would drop this in my finding details, because when you say things, you can attest whatever, guys, when you deal with security, you can attest whatever you want, but they're gonna come back and ask you to prove it. So this is actually, this checklist, this tool here allows us to save this checklist and say, for werewolf node whatever, we are at a 96.46 adherence to our STIG score, and here are all of our finding details. And then you don't have to typically put comments, but you can say this is correctly set or whatever, or it was correctly set. You can do whatever you want there. Typically people don't care this much. They care that this is correct and then that the details show the system and the fact that it was set the correct way that it was supposed to be set. That's what they care about. Then if they do an audit later and they find it's different, that's something else. That's something completely different. But this is you, like with all security, you do your own internal reviews, your internal builds and audits. This is security engineering stuff for us. Then we push that forward to whatever team then checks it off, and they look at it and go, okay, this system's ready to go live. This system's ready to be connected to whatever internal, SCIF type environment that we're in or whatever. All right, I'm going far afield. We're just supposed to be talking about building shit. Anyways, a lot of that stuff that I just showed is in the security engineering course. So some of the security engineering guys did that kind of stuff. Do you use an automated tool for compliance, like defining the rules and running them against machines? Yeah. So Craig X, what I typically do in my environments is I run, when I build stuff like for big systems, I typically have a certain set of images that I'm going to get to build. And in my image list, in my home lab, these are my images, right? So these are the things that I have to harden. So when I go to run those Ansible playbooks, like if I was going to run those Ansible playbooks against one of those, let me show you how that might look. So I'm down here, I'm here, and then let's look at my site.yaml. So this is where it's going to, let's say I was just going to apply all of these STIGs to something. And let's make one that's safe for us to try to bust or mess with. And so we'll say www.ctl copy image, and let's go Rocky Linux 9 to it's image copy. Sorry, image copy, because it's a full keyword. I think CP might still work. And then we'll say Rocky Linux hardened. Oops, hardened -9, right? Something like this. So it'll copy this, and then I'll show you where the cheroot is. And then we'll go and we'll make these cheroots here. We'll make like a hardened one. just for now, and then I'll show you how I would run this in my environment. Yeah. So I do, yes, I do automate my compliance because, again, everything we do, like you saw me doing that stuff individually in the device, those things are fine to one-off stuff. But 461 times or whatever those are, I'm not gonna one-off every one of these. So there's an OpenSCAP scanner that will then scan your compliance and it finds like, let's say like 80% of them, and some of them you do have to manually go back and check. But I'd rather do that on this image one time, right, and then not have to do it multiple times, right? So watch this. So we're here. Where is that, right? So you say, well, where that copied something to something, but where did it do it? Well, if I cat cheroots in here, this is where it is. So if I cd to var, we can actually just copy cheroots to, let's do hardened. You don't have to keep, like, names are always annoying, but you don't have to keep doing that like I'm doing, but I'm doing this. And then this is going to be, his root FS is going to be Rocky Linux, what was it, hardened? 9, I think. Is that right? I don't remember. We'll go images. There's our image. So Rocky Linux hardened 9. VI cheroots, Rocky Linux hardened 9. Get rid of that one. Sure. We can validate that that's, if I do an ls-l on var lib werewolf cheroots Rocky Linux hardened 9, right? We see that that's there and it was just created, right, today. So now I can modify that specific environment through an Ansible cheroot, which is right here. And I can run this playbook. This playbook's probably going to fantastically break, but that's because, well, because certain things aren't stood up in a cherooted environment. So some of those things I'd have to pull out. All the sysctl are some of those. But let me just show you how I would run this. So Ansible playbook -i cheroots and then site.yaml. So this should run, yeah, against that one environment. Let's see, this is a break everywhere, but we can at least see that it's going to go try to apply some of the stigs to it. Gathered facts, went down in there. It started finding some things were already good, and then it's gonna. This will break, guys. Don't be surprised about that. But it's because I haven't modified it for this environment. But it did change some things. It did just fix some things. Now it's skipping some things it doesn't need to do. It'll break on sysctl because it can't check the command. Sysctl is not up. SE Linux is installed. Couldn't resolve a hosting. Oh, so I have in this one I have a busted. I could actually fix that and get past this one. I can show you that if you guys want. Watch this. Cat hardened cheroots. And then I can cheroot. Oh, we'll do it this way. WCTL image. Hold on. Yeah. So we can just container exec in to that, right? Boom. And then... Oh, that's my old way of doing it. I know I have a newer way of doing this. Hold on real quick. I know I have a newer way of doing that. So I'm using a newer version of Werewolf, and it has some different command sets. And we can do this. We'll get away with this. We want to go into Rocky hardened. Right, so we'll drop down into that environment, and I'm going to VI in here his Etsy resolve.conf, and in here, oh, he does have a name server put on there. So why wouldn't he be able to connect out? Hold on. Search. Let's do it this way. Okay. Whoops. Interesting. Can't modify it in here, huh? Oh, you know what? Okay, well. Can't modify it in there. Let's just CD to where he is. Huh. We'll just modify them here. Don't really actually care. Oh, actually, should they both be search? No, I'm doing this wrong. My bad, guys. That should be search. How does it look out here? Yeah, that's right. Why didn't that work then? That's weird. I don't know why. That should have worked. I mean, we knew it was going to break, but the point is, we could go see, you know, where it was going to break and then try to remediate things. I was thinking there was a DNS problem here, but I was resolving so I'm not sure exactly why that's not resolving out. But we go troubleshoot that, and if we wanted to do that, or I can actually go in there and just fix those things manually. This is probably still going to break in the same spot. But the point is, this is how I would harden a box right here for people that wanted to see the process. This is going to be built into a Killer Coda lab because I can actually build the Ansible. Yeah, it just can't find. Why is it trying to find? That's weird that it's looking for Fedora project. We'd have to go figure out what's going on there. But and maybe I have newer. Yeah. So I mean, I probably need to just add all these repos in there anyways, because I have such an old version that it looks like it's going off of the CentOS. If you guys saw the error, right? It's going off of these other, it's like a Fedora project, something pub. What the F is that? I should be using these. So I probably, what happened is I have an old version of the image. I need to update my image and do some lab maintenance and stuff. I think my image is about 1.5 years old, so I need to pull down a new image, go through the process, do all my lab stuff again. I just haven't gotten around to it. All right, but this is, guys, this is so you know, this is how we maintain systems like that. Then that's part of the build process. So somebody might ask you, hold on real quick. I gotta. Hold on. I gotta send this to the wife real quick. Sorry. All right. Okay. So that's that's a real high level. Like I'm just like trying to spitball that in the lab, but that's the process that I follow for anybody that needs to see that. And I don't know. You know, I think in the Linux automation course, I kind of glaze, or in the security engineering course, I kind of like glaze over that. I don't really go deep into that, but we are doing that. We're in a pause for the automation course until January 3rd. But that is going to be one of the things we do next. I have to spend some of this time where I'm on vacation here to, actually I start vacation today technically. So I'm going to be off for the next 2 weeks. And then I'm taking on-call over Christmas because I don't care, I'll take on-call. Then like maintenance of security, right? So security, once we build a system secure and push it out into the world, things change, right? So I go like Rocky 2. And this guy he's as good as he can be, but SS-NTULP, maybe somebody changed something on him. Somebody added a port, or we got port 9100 open for Node Exporter and 9080 for Promtail Linux. Maybe I didn't expect those to be there. Maybe I need to ensure that, this is one of the reasons that host-based firewalls are so important in an environment. What if somebody accidentally deployed with Ansible across my whole environment Promtail? And Promtail does a cool thing with logs, but maybe that port is exposed now on servers that are out in an environment that shouldn't be exposed. Well, if you've got a host-based firewall, that's a mistake, and it's not good that somebody did that across the whole environment. but you have what's called a mitigating control or a compensating control, because now you have something layered over the top that doesn't allow port 9080 to be open. Port 9080 is only open if it's open here, turned on, and is allowed through the firewall. So that's why a lot of times people will add a host-based firewall to a system. So if anybody asks you, why would I turn on a host-based firewall? Well, it maintains a security posture that we have approved, even if somebody makes an administration mistake. That's a good way to put it. That's a good way to think about it. It's another layer of security that prevents problems from or real vulnerabilities from occurring. Yeah, again, because if and you might say, well, what's the danger in Promtail Linux being there? Well, there's a few dangers if somebody accidentally put it there that shouldn't have. Here's one of them. If it's been put on servers that it shouldn't, but then when we maintain them, we get the right list, we're no longer maintaining that. It's not in our inventory of things that we think are out there. Then now we've got this problem where that doesn't get patched. And now it starts to feed into common vulnerabilities, and CVSS starts getting found against it. There's scores and vulnerabilities are found against that version of a thing, where the rest of our environment doesn't show that version. So now this is why we have to have security operations maintaining and managing things as well, where they typically just audit things and show it to us. But now I have to go figure out, oh man, why the hell do these 30 servers out in the DMZ have this extra port open that they shouldn't? Now, granted, yeah, we're protected for the most part, but we anyway, so that's the thing that we do. So maintain, you should use ss-ntlp, ntulp. You can use any thing that you want after ss, and it will show you like this. SS is where netstats kind of go. Netstat doesn't even exist on Ubuntu anymore, and a few other types of servers. So SS is the more preferred way to do just seeing what you're listening to for both UDP and TCP, right? And your posture is going to vary based on if we're doing internal stuff or DMZ, and it's going to vary even more if you're air gapped, right? So that's something that's if somebody asks you what would be some considerations around how you would set the posture of a system, I would say, well, if it's internal only, I may have a slightly different posture than the DMZ. Now, if you're doing like zero trust, you're going to get your hand slapped, because that's not correct. Zero trust treats everything as though the only things that can talk to things are through certificate management, and you use your PKI, your X509 certs to talk to other devices and services and that kind of stuff. And that gets real complex, which is why we use tools for it. But if somebody were to ask you about that, we could go and we could kind of see what's going on. Hack the Planet, 3-stream streak. Nice. Nice. I always appreciate you hanging out. I'm just talking a little bit because the wife is getting off of work right now, and then she's going to go grab us some food, and then we're going to... okay, let's see. Julie is leaving work now. Okay. All right. Sorry, guys. I probably got about 30 minutes where we can keep talking about this stuff. But all I'm doing, guys, is I think I even put it in the chat or the messages. Linux admin engineering job requirements for getting knowledge in the field. How do these jobs that we see over here, right? There's job requirements, and how do they kind of tie back into like what we're doing? And then we had gotten down to here, and we're maintaining. You got to remove old unused software in a system. Like if you're not using. Now, this is a lab environment, so we got all kinds of stuff out there. But I'm going to show you guys something. RPM QA, and then let's just do word count -L. We have about 651 packages on here. In my servers that I build that are like high performance compute stuff, my compute nodes tend to have under 250. I do not have a lot of packages on there. But let's see what packages are there. Maybe I want to grep for, I don't know, OpenSSL maybe. What are my OpenSSL libraries, right? And then I could manually by hand go look up my OpenSSL versions against the CVSS database, right? The common vulnerabilities and exposures from NIST are available. You can go query the database right on their webpage. That's not super efficient, though. Do you guys think I want to be doing that by hand? So that's the value add, right? We talk about like how a company spends, I guess these. We talk about how a company spends money and why they spend money. And the value add of companies like You have a company like Tenable Security or Qualys that are constantly scanning your systems. The value they do is they go look for this open SSL libs 3.2.2 on my system, and they basically enumerate everything in my system and compare it. Thank you for that, Sketch. The bless you. Yeah, I appreciate that. They compare this. Oh, let me move this up so you guys can see your chat better. They compare you with what you have in the environment to all the vulnerabilities that are out there, and then they give you CVSS scores, and they give you how red your systems are and stuff like that. And that's that game. If you guys ever wonder, like, what's this game of vulnerability management? It's you taking your versions of stuff and comparing it to a known national database. Could you do that yourself? Absolutely. You can go make API calls yourself against that database without a developer key. In fact, I think they allow you to do 10 a minute. So that's every 6 seconds if you wanted. You could have a database. But as I described this, do you guys want to be in that business? It's a very lucrative business, guys. But the big players in it are like Tenable, Qualys. I imagine Falcon Strike has some stuff like those guys over there. What are they called? CrowdStrike, but they have the Falcon sensor, so CrowdStrike. Those are the big players in that game. But what are they doing? Guys, they're going against a fucking national database. You could do that stuff yourself. You could set that up as like a project in college for fun and probably, get some hits and get some support. But that's what those open vulnerability scanners, that's what they're doing, is they're comparing against those databases. So my point in saying that is remove hold on used software. If I wasn't using OpenSSL, why the hell is it on my box? Now, you might say, well, Scott, how often should I audit stuff like this? Well, typically the best way to do this, like if I said, hey guys, I've got like 1,000 chickens in a coop right now, and I'm gonna let them roam around this field, but I want to tag them. When would you probably say the best time to tag those chickens were? I know nothing about farming. I've had friends that have had like 10 chickens or something, but I know nothing about farming. But I'm gonna tell you one thing I know for damn certain: it's way easier to tag those chickens before you let them out than when they're running around in that field. How do you know you got all 1,000 of them? How do you know some of them didn't die, right? I mean, so my point is, security operations are always better to do when you first deploy things. That's why I'm telling you, I keep my systems as lean as possible as I build them, as few things on there as possible. So anyway, so then you clean stuff off. I actually have a couple of one lab for sure that talks about removing older packages in an Ubuntu environment. And then we should audit users, right? Like, when are users logging in? We don't want to be in the business. A lot of times, me as a Linux engineer, I do not want to be in identity and access management. Identity and access management are their own people. They're smart people. I'm not saying they're not smart. I'm not saying they're not engineers. They're just not in a field of engineering I want to be in. I do not want to keep track of who's in a system and that kind of stuff. But as Linux engineers, we have to give those people access to our systems. So we need to understand those methods of how we give people access to systems, right? We can give them access with, for their users, we can tag groups, and then we can allow, there's a Etsy security access.conf, which is a very common file that will modify and only allow users within a certain group tag to that server. And then this is one of the things I like. Have any of you guys ever seen, has anybody here ever used a realtor, went to buy a house? You guys ever seen a realtor lockbox? It's one of these things. And it sits on the outside of the house. And your realtor, when you meet them to go check out a house that you maybe want to buy or you're doing whatever, they don't have a key to that house. There's not 10 million keys for that house floating around for all the realtors in your area. There's one key, and it's locked in a lockbox outside of the house. And they get told the password or the key, or sometimes they have a little digital thing, and then they can open it and get the key to that house. Well, this is what I do in my Linux in my Linux servers so that I can avoid identity and access management stuff. I set the access.conf file to allow the group, and then the identity and access management team puts the people in the group, and then those people come in, and if they're in the right group according to LDAP, getting into my system, they can come in and do whatever they need to on the system. That's different than sudoers and additional permissions that they get. I'm just talking about access to the system, being able to get in and log into a system, right? I don't have any labs that do that or show that, but I do have a lab for, and we're just going through everything in our security engineering course. We kind of touch on that. Oh, this is the admin course. In the security course, we kind of touch on that in the user access, just a little bit, in that we allow LDAP to come in, but I didn't lock down the LDAP implementation anyway. We could have done that. In fact, that may be a good thing to do in future labs. But if you want to see how we allow users in, it's here. I didn't limit them inside of access.conf in here, so that other part I described is not in this lab. But this lab is, it's another lab that shows you how to go build. We had to build our own LDAP so that we could connect into it and stuff. But okay, that's neither here nor there. And then you can track how users are logging in with Fail2Ban. I love Fail2Ban. It's a great tool. And then we can send that to Loki and Grafana. And we do have labs that show you how, this is back over here, with monitoring and alerting, when a user logs in and fails and breaks their, they're failing to log in or failing to sudo up, we can send alerts out to like Discord or something like that. And some of you guys that have been in our Discord for a while have seen that process happening, because I give a API, we have a webhook, right? And you can see where people were finding, these are my normal daily checks. This was somebody was doing something, Sam Quinton, and then somebody else, like people were sending stuff in. And then I showed the little sand art thing that I got for my wife, which I thought was funny because it's in the Sandbox channel. All right. Anyways, let's see if we can find another one. It's not all serious around here. It's actually funny. It's very unserious in the Discord, but I'm serious here because, that we only have a limited amount of time. So I try to make this stuff somewhat valuable to you guys, right? If you're going to spend a little bit of time with me, I want it. Same thing with my college students, right? Like this may be the only time that you're not breaking rocks all week. And this might be the only time you get to hear how an engineer talks about things. So I'm going to try to make it valuable for you, right? These are all my checks. These checks go daily. Different checks. One of our guys was doing... so this was a different check. That was when systems rebooted. I think Kolkus sent something in there the other day too. He was just doing a check on like ZFS pools though. Yeah, he was just doing ZFS pool check in an environment. And could he put that out to, and this right here, by the way, when we get into monitoring, you go, well, what do you want to see? Well, you don't want an alert to be too much, but you do need it when it's like an actionable alert. And that's why I would tell you to go read those SRE Google books on, I mentioned I linked them earlier, but the SRE Google books are, when do we alert? What? Because you'll get alert fatigue. Alert fatigue is a real thing, man. That kid keeps crying wolf, and the system's still up, but he's still crying about a wolf. You're not going to really go out when there really is a problem, right? So alert fatigue's a real thing. But I love sending stuff to like just a channel, and I tell people mute the channel if you're not the on-call, and then open up the channel when you are. And then I like to just see that my environment is clean every morning. All my systems are not unreachable. If a system's unreachable, that means Ansible failed to do something to it. Well, every morning here, I know that my environment is clean. Now, does that mean that all the things in my environment are clean? No, there could be other problems, but we exist in a stateless environment. So if a box is up, there's a good chance it's limping along pretty well. And that's kind of this is just a nice little heads up check every morning. And again, I haven't even looked in here in a while. You can ignore it if you want, right? People ignore this channel. They don't, it's not like I'm alerting everybody in Discord or nothing. I don't know where I'm going with that stuff. All right. You need to know how to manage user accounts, permissions, and file systems, right? Etsy password, and audit to make sure that people don't have more permissions than they should. Your Etsy security access.conf is how you can limit security. And I need to, again, put together some labs on that. I just don't. We can trust external environments. Windbind Samba is the really old way. We don't really do that anymore. SSSD is the more modern way. Then IDM and Keycloak are, IDM is a Red Hat proprietary one, but it's they do have it free for people to use now, so you can use that without paying them. And then Keycloak's an open source one that works pretty well. And you can trust environments, and then you can allow people to log in. I might even say it's not necessarily a trust environment, but you can use password checkouts and a client through Vault, HashiCorp Vault, and you can do some interesting authentication stuff for users that way if you wanted to. I feel like I've looked at that, and it's almost like you'd have to layer some automation on top of that to make that one really functional. But it does have some cool implications that people can check out from the HashiCorp Vault and then get credentials that only exist for that session. Nobody's running around with like keys or other things. They're checking out from HashiCorp, and always, there's like a full trail of exactly who did anything. There's some interesting like concepts there around user tracking and stuff. But can you check permissions on directories? You got to know your access control list. You got to know your 755s and your 644s. You got to know what those are, right? If you don't know those, you got to learn them. And there's a lot of places to learn them, but we could just go here and just look at everything, and then we could tell a lot about what's going on in the system. Now, real quick, something that I like to point out to people sometimes is you've got all this information over here that's being shown in color. That's not always there in older Linux, and for sure it's not there in older Unix systems. Modern Linux, I tell people it's going to be there, so I'm not going to tell you you can't use that. But that is actually formulated by an alias. That's not part of the ls command. So if I do an alias command real quick and see all my aliases, if I unalias ls, just unalias it, it'll only be for this session, and I go and I look at my ls-l again, I don't get all those colors. Well, that's annoying if I'm used to it, but I still know this is a directory. But how do I know it's a directory? Well, from being a Linux guy for 25 years, it's got the D over here. It's a directory. If I didn't have this where it showed me bin was actually linked to user bin, that's a visual that's not always there. But I know right here that it's a link. I know right here that that's a link to another directory, right? And there's just a bunch of information here. Root right here, which is in /root. We're in / and we looked at ls-l, so we're looking at the / the root of the file system. We know that root's home, which is /root, is 700. So it's a directory, and then it's read, write, and execute permissions for the root owner. It is 0 permissions. There's no read, write, or execute for the group owner right here. And then it's no permissions for everybody else in the world, which isn't defined because they are defined by exclusion. If we were doing a Venn diagram, everybody else in the world is defined by exclusion from not being in the group owner. This is the user owner or the group owner of that file. That's what the definition of everyone else is. But it doesn't matter here because they don't have any permissions, right? So these are the things that we kind of need to know. If we go to a company and they say, hey, do you know how to manage user accounts, permissions, and file systems? Yeah, I know how to manage them. We want to talk permissions. Do we want to talk about how we let users into a system? You tell me, like, how do we do it now? Oh, it's all manual. We got to build a user and then we got to push them everywhere. Well, that's okay. That's a way to do it. Do we have all the users in like a tool like Active Directory or something? Do we want to connect IDM as a centralized location to pull that information, and that can trust Active Directory in our company, and then all of our servers can point at that? That can be a project I would take on, or that could be a thing that we could build as a more modern and standardized way to do it, to remove what we would call pain points, right? Pain points are a thing that admins tend to think about, and engineers don't as much. But hold on. If I'm an engineer that's also going to be called to like fix things late at night if something breaks, then it behooves me to understand the pain points so I can fix them. Now, look, all these things aren't necessarily going to be look, I've already been talking for an hour and a half. I wouldn't necessarily be talking about all these things in an interview. I'm not like giving you guys like my interview tips or anything. I'm just talking about things that you might get asked. These are all of these numbered things here for people that got in here later. They are directly from a job that I found on Dice a few months back. We were sitting around talking, and I grabbed it, and then I just started adding my thoughts to it as we went. And that's all we've been doing today. One was perform. Look, so they want you to be able to perform routine system backups and disaster recovery procedures. Keep our Linux systems ready to go, maybe push data back and pull it and prove that if we delete a file, we can get that file back. Well, there's this plan, like if somebody said, how would you set that up? Well, there's a common methodology that people use. We use 3 copies of data. We have 1 in prod and 2 in backup. Those backups are kept on at least 2 different types of media. So if I have spinning disks here, now SSD disks and spinning disks are not, in this case, I would just consider those block devices, right, from a Linux standpoint. So that's one type. Tape, that's another. Network storage could be another. And you say, well, network storage is on SSD. Okay. But it's a different type of media than the one that you're on. It's locally attached block, network attached, tape, those kind of things. and then one is always off-site. And what off-site saves you from is your ransomware. It doesn't save you from. There's two components to ransomware. One, they try to read your data and sell it, which we can protect by encrypting our data at rest. And two, they try to further encrypt your data so you can't use it without their decryption key. That affects your recovery time objective. And also, they hope to affect your recovery point objective, so you just pay them. But if you've got an offsite backup and you can pull it and you can get it loaded, now as long as that's within your acceptable time to solve a problem, so that's your recovery time objective, let's say you can do that in under a day and get all the data back, then you might just be like, well, go kick rocks. Clean them out of the system. Don't pay anybody anything. We've kind of protected ourselves. But this is the base standard that like a lot of companies will build. Is it the only standard? Absolutely not. I've worked on systems that are way crazier than this, but this is the idea here. Okay. Just saving data offsite is not a DR system. That's true. And until you've tested data recovery, do not have a backup solution. That's 100% true. I wrote these a long time ago. That's true. Let me tell you something else that is also just having a HA pair of systems is not a DR solution. What do you mean by that? Well, I have a load balancer and I have 2 web servers, or I have 5 web servers, 7 web servers, and they're good. Okay. But if the data are corrupted, that they're all going back to serve your static content, that data that's back there gets corrupted. Doesn't matter if they're highly available. They're all highly available off the thing that got corrupted in some way. So we need to be able, that's not a DR solution. That's not disaster recovery. Now, we're not going, I'm not trying to make you guys DR people, but before you do disaster recovery, you got to do, and before you do business continuity plans, which come before that, before all that is a business impact analysis. You look at all the processes that make your company money, and then you think, well, what keeps this running? What keeps this thing afloat? And if something goes down, what's the impact and what's the cost of it? That's what a business impact analysis informs. Your business continuity plan informs your BCDR, which is your business continuity and disaster recovery plan, right? So business impact analysis first to look at processes and procedures that make you money. Then, and I don't have a talk on that, but I mean, if people want to do a talk on that sometime, I always tell you guys, like, we've been building all these courses, but maybe going forward, and I'm going to try this out a little bit, because I feel like people get really hot in the pan and really want to do something, but then they cool off over time. So like not a lot of people finish the courses. What I might do kind of going forward is do like little, like 4-hour, just like intensive blocks down in the Discord. And it'll just be like some pre-work probably to get ready, whatever we meet, and do some like labs and stuff with people and talk through some stuff, and then maybe like a little project display or something. Like we're probably going to change the way that we're doing like the ProLug stuff, because I'm not saying that this isn't good for people. I feel like people, life gets in the way, so a lot of this stuff's hard to do. But if I did like a day intensive, I think people would really RAID is that's 100% true. Mind your own business. That can I steal that? Because that's 100% true. RAID is not a DR solution, not even close, because it's all hot. And if we're talking about ransomware, if they compromise the process that can touch the data are lost, right? The data, I mean, now we need to either move data back over time. That's 100%. Yeah, I got to steal that, because RAID is truly not a DR solution either. It's a great continuity solution and it solves a lot of problems, but it's not DR. That's 100% true. 100% true. Yeah, there's 100%. In fact, I do have a talk on ransomware, and I haven't. So I did this as a part of a bigger thing. Here, I'll pull this up for you guys. This is in the Discord as well, if anybody needs it. All this stuff that I'm showing you guys is up in the Discord. But I did this one a while back. Whoops, hold on. What's going on here? Get out of here. Let me find the right. Here's my ransomware one. Let me get this out of the way. I have no idea what I just did. Did I just kill my damn... Okay, there we go. This one, I gave this one when I was still at AAA. That's funny. I originally gave this as a... So I ran a Friday, just like a lunch and learn. So there's some stuff in here that you guys are going to be like, man, this guy's crazy. But it was for our people that were getting ready for their certifications. So don't worry about this. This was and this was when I was on my path for my Solutions Architect Pro. I was just writing things and doing things that I thought that people would think was interesting. So this is up in the Discord as well, but it looked like this. There was some policy practice stuff I would always do with the guys to practice, because every test that you're going to take, if you take an AWS cert, is going to have policy management. And then this was, here's my references. If you guys need this, again, it's in the Discord. But this is, reference blogs. So there's some good AWS blogs on this stuff. And this was for an AWS group, but I was talking ransomware for the company and then in general. Ransomware challenge, how does it work? Here's the problem with ransomware. There's two things. They want to get your data and sell it, or threaten you to sell it. That's the first one. And the second one is they want to encrypt it further and then be able to charge you to get the decryption keys. Both of those things are insidious. They're problematic. They're terrible. But the first one can easily be avoided by keeping your data what we call encrypted at rest. If our data is encrypted at rest, so when it's sitting there, it's not readable by average processes, then we protect against that first one, but not the second one. If you get we protect our processes by not letting our stuff get compromised, but that's something that is, as we've seen, an inevitability. People are eventually going to compromise your systems. So all things are eventually going to get compromised. That's a truth of like engineering. Like all passwords are eventually going to be known, all these kind of things. So we have to deal with entropy and changing and this kind of stuff, right? And that's a whole different talk, but it's important. And they want to sell your secrets, but you can keep them locked. But then they want to keep you from getting at your secrets, which is a problem. So that's the ransomware challenge. Those are the two major threats here, right? And how does it work? It kind of looks like this. They force an encryption key. They will sell you back the key, and they want to take out the confidentiality of your data. But if they can't get at that because you've protected yourself, that's one way. Keep your stuff secure. But they have damaged the integrity of the data, meaning the data is changed by unauthorized processes, and now you're not available to get at the data because it's encrypted in a way that you can't get at. So they've managed to get these two, but maybe you protected the first one. That's the idea, right? Hold my beer becomes hold my beer. That's funny. What doesn't work against ransomware? This is that same idea of RAID. The server's crashed. Where's the backup? Well, it's on the server. I found that meme on the internet a few years ago, and I'm like, that's the funniest effing thing. Because I've been here with companies like, hey, can you get this back for me? It's on this disk here. And I'm like, I mean, maybe, but like, and they're like, oh, here's the RAID disks. And you're like, oh, shit. I used to have to do this at Lockheed a lot. I had a buddy who would go up, and he was doing, he was one of our research guys. He would go up in an airplane, and he would be at like 10,000 feet. There'd be no pressure in this plane. He'd be on oxygen, and then he'd come back, and he would have frozen disks because he was operating the disks at like 0 degrees. They would be unpressured because they went too high and it blew the pressure. Because I don't know if most of you guys know, spinning disks are pressurized, right? When you break that seal, they are sealed. He would blow those, and then he'd be like, Scott, can you get the data off these? He'd be like handing me these disks, these old hard drive stuff when I was at Lockheed back 15, 20 years ago. And my buddy would hand me these discs, and I swear to God, it was like, they'd be cold, first off. It would be like a cartoon where there's like icicles hanging off and stuff, and you're like, what the fuck do you want me to do with this? And then he would ask me, he's like, hey, does it matter that I like have the server rack in an airplane? Like they would go up in an airplane. This guy was a research guy, so he had all kinds of dudes that would help him do whatever. But he'd go up in an airplane, he'd have a server rack in there, and he'd be gathering data on the satellite downstream stuff. And that's what this guy did, was just research stuff, and had a team of like 50 people that followed him around. That's a pretty cool job to have, I'm sure, but that's like a research position. And he would always just hand me these disks and be like, Scott, can you get data off them? I'm like, fucking hey. So I'd get the data off them for him, but it was always a mess, like rebuilding RAIDs and stuff. But anyways, not my point is the server's crashed. Can you get the data off? And they just like hand you a pile of parts. That's literally happened to me a few times in my career. Good buddy of mine. I love talking to him, but he was. I'm not going to diagnose anybody as autistic, but if there was an autistic person that I've interacted with in engineering, and I imagine there's a lot of them, he was one, because he'd be like Rain Man, like talking in the corner, drawing shit on my dry erase board and solving stuff while we were hanging out and talking about other stuff. He was a very, very smart guy. But anyways, so what doesn't work against ransomware? This is a bunch of that stuff. High availability does nothing to protect against it. So this was my bullet points. Encrypting data at rest does protect the first part, but doesn't stop the second part. Immutable database or backend writes can slow the spread, but it doesn't really stop the problem if everything's connected to one master database that propagates back, because your problems are going to get propagated in real time. So ignoring the potential problem and hoping it goes away is not an acceptable thing either. So what does government say to do? There's a bunch of things here. This comes directly from the government standards, right? But then down here, this is what we were dealing with. So I was actually in this one, I was showing how to use the AWS tape library service with Bacula. That was the point of this presentation, if anybody cares. And then I said, what does work? True offsite backup is the air gap from the original system. Air gap is kind of like Magneto have to be kept away from metal, because if you get any metal near him, he just kills everybody, right? So you had to do like a fully air-gapped data. Your data has to be in an unwritable format somewhere. And then tape library, this is the way that, this is actually one that I set up. I run one of these currently at 2 different locations. This can store exabytes of data in it. Each one of these is petabytes of data. No, these are high terabytes of data right now. There's a lot of data that can be stored on each one of these. So a lot. This old powder horn, I always tell people I worked with powder horns at Lockheed Martin. You can't go in them while they're energized before you've made sure they're completely powered down, because that arm will kill you. That arm will rotate around and kill you. And that's that. Which government? Well, I'm typically talking about the U.S. government where I live. That's the one that I normally work with. But I imagine other governments have similar stuff. But typically this is the U.S. government. I get most of my stuff, if anybody's wondering, is from NIST publications, because I work with NIST quite a bit as far as their stuff, and then AWS. All right, so yeah, government is typically U.S. government. And then here's some of the tape stuff, like how much space you have on these. And this was gathered a while ago, so I'm sure there's even higher tape sizes coming out. Look at this. Compressed data, 360 terabytes on one of those. Massive amount of data can still be stored on tape. Don't think people aren't using tape. Chuck in game, I am a professional, yes. All right. All right. I only have a little bit of time left here, but install and configure server hardware and peripherals. This is the next part. We don't have to go into that too much, but these are different tools and agents that are around to do that kind of stuff for you. But we'll install and configure hardware and peripherals. So making sure that the stuff is there that you put into like a physical machine. Like let's say you go to a data center and there's 10 physical machines, and then you go back to your system and you do an LS PCI and you see that the stuff is installed like we would have expected, that kind of stuff. LSUSB can show you some stuff if it's there. I don't have that on the system. And then maybe LS mod to look at like what kernel modules are there. And maybe I expect something like ETH to be there. Maybe in this case, what might be one? Net. So what are my network modules? And then I can see if some servers are not similar to others, and I can see if like something didn't load. Dmessage, when we boot a server, will show us all the things that have happened since that system booted. So if some PCI, I expected some PCI bus to be populated in some way and it wasn't, then I can check that and I can see that across a list of servers. All right, well, hold on. Ban turd. There we go. All right, the guy is gone because fuck him. I don't know who that guy is, and I don't know why he's talking to me like that. But it's always funny to me too when people come at me sideways. I'm like, there's no way you would talk to me like this in real life. Like, no way. What's standard entry tape machine these days? I don't know what a company might use, but we could have had it all. I would tell you this. And this is in the talk, but I had kind of dropped it off. Instead of paying for tape libraries nowadays, because it's a pretty big entry. Like, I mean, it's maybe a few $10,000 type amounts to get into tapes, right? Tapes are not a cheap thing to get into. If we drop down here, it is much cheaper as like a company. If you wanted to have a virtual tape library and be able to send data off to AWS, you could do that for almost nothing. In fact, in this lab, when we were kind of doing this, I made people go to the cost calculator for AWS and look at, if we were to send data off, how much would data cost for us to move like this? So we use a tool like Bacula, and we move data up to like there's a it's almost like a pretend tape drive on your system, and then we move that tape drive and it goes up to AWS. So now we've got a backup off-site that is not in normal processing, so it follows that backup, but with tapes that we can call back immediately if we need to. Normally, if we move tapes off of site, you've got stuff like Iron Mountain or somebody who you have to bring back. By the way, side note, guys, for people that don't know what just happened, somebody came in and was talking shit to me or whatever. Said, "Are you a professional? You're not talking like a professional." He gets banned forever. And if I find him in Discord, he also gets banned there. I just need people to know, like, if people come at me sideways, I don't even deal with internet bullshit. I don't care, right? Like, I'm a college professor. If you did that in my college class, I'd kick you the fuck out of my college class. I'd probably tell you to stay the fuck out too. Like, you know what I'm saying? Like, people act like this on the internet because they're safe, but like, I'm telling you, IRL, most people wouldn't even look me in the eyes if they were going to talk like that. But anyways, that's neither here nor there, right? I'm not threatening anybody. I'm just saying, like, people are assholes. And like, I feel like this is like free. Like, I'm telling you guys stuff that like people got, paid to do. So anyways, yeah. Smitty, I don't like that guy's going to go learn someday. And then like, he's going to get quote, like I have a buddy who was over here the other day. He's a director at GoDaddy. Oh, actually he left GoDaddy. He's a director at PayPal doing audit. And we were talking the other day over here at a party of mine. And he was like, yeah, when I was sitting for my CISSP class, and we were talking with some of my jiu-jitsu buddies, he goes, yeah, there's a quote that came up with Scott's name on it from this professor, Dr. Bill Curd, if anybody cares. And Dr. Bill Curd had me in his presentation. He was quoting me on his CISSP training that he gives people all over the world. And Matt was like, yeah, I saw that. And I was like, I know that guy. And I was like, that's funny. So anyways, my point is somebody's going to come one day and be like, oh, I was an asshole to that guy that was trying to help me out. Well, good. I hope he has as hard a life as he deserves. Anyway, so here's a bunch of vendors that are supported with this virtual tape library. So my point is you don't have to go buy a virtual tape library. Like these things that we used to have to pay, the entry point on this is probably about $100,000 for this box, not including the tapes, which are about $300 to $400 each. You can get them packaged up on Amazon if you wanted to, but a 10-pack is a few grand. Yeah, but there's a lot of density to the tape, and then you can send it off site. But what if there was a solution, and then this is our RTO to RPO when the incident occurs, our recovery point objective versus our recovery time objective. But what if we don't have to call Iron Mountain and get disk tapes, tapes back to load into that system and then take 16 hours to run? What if we could go right to our cloud, bring it back and run it and start recovering our data immediately? We could do that. Hold on. Are you here? I think the wife might be home, guys. She got off work a little while ago. Wife should be home soon in a minute. All right. Finding it. And then we did pricing. So if you wanted to do like storage gateway pricing, or if you wanted to look at this, and then Bacula is just a great tool for backing stuff up. I use them professionally with some government projects. And then I need to set them up in my home lab. Actually, I need to set this up in my home lab, especially with like my dissertation work. I don't want that I have that locally, and then I have that in a local internal network store. But I do need to follow my own advice and have this backed up somewhere. So you could use Bacula for that. There's really good resources online for Bacula, but to learn it, but to practice it, we need to make some killer Coda labs for it. So those are in my backlog of labs to make. And then moving on-premise back up to the cloud, this is one of the easiest like AWS wins to get for a company. If you want to go to AWS, you would have something like a tape gateway. It's sitting on your system pretending to be a real tape library. Your service, like Bacula, interacts with it as though it was dealing with real tapes. But those tapes are actually being stored up here in the cloud and archived at the lowest tier of storage. And then if you pull them back, there's a certain amount of time to pull them back, but you can also pull them back, as at your leisure. And it's a lot faster than the old tape method like Iron Mountain. Iron Mountain's a big company that does tape management and services and stuff like that. And that's a service fee that you have to pay for as well, so you can save that in some ways as well. All right. I do have to get off of here, guys. But what were we doing today? Like assholes aside, we were sitting here. I was telling you guys about just the jobs, right? Like what does the job look like? I was walking through the different things that happen in the job. These were the actual tasks that people were asking for, and then these were kind of my notes underneath of the things that we would talk about. This is up in the Discord. If anybody needs the Discord, it's right here. It's free. I think we just hit 4,400 people the other day, so it's pretty big. Yeah, and Craig X, hopefully the Killer Coda stuff shows you around and makes this stuff. Like, I try to, like, I tell all the senior guys in our Discord, like, I'm like, hey, our job here is to make this easier for the people that come after us, right? Like, a lot of us, like, we had to, like, plow through and learn these things, you know, where we could, and, like, learn things as we kind of could. But we're trying to make the task of learning these things easier so people can get in these roles. There's good money in systems administration, and then there's even better money in systems engineering as you kind of move into some of these different roles, and you can have a really rewarding career. You don't need to go to college, although I am a college professor and I'll talk to you all about college if you want, but I don't think you need college to do this. But, you know, again, then you got some of those people who just want to shit on everything, and, you know, it's like playing playing chess with a pigeon. They're just gonna crap all over everything and try to trip me up. So, all right. Collaborate with other IT professionals. All right, so there's a bunch of things here that you guys can do. And again, this is already up in the Discord. So I'm going to go to my little end of stream. I appreciate everybody coming. I will be around this weekend, but I will probably be doing research stuff. So if you see me in Discord or any of that kind of stuff, I'm probably going to be studying. But if you want to talk through anything or hang out or anything, let me know. All right, I'll talk to you guys later. Take care.